Hi and welcome back to Gaffey's Grinds for Junior Cycle Science. This is video 12 in our module on particles. In our previous video, we looked at the idea of a mixture and how we can separate mixtures. So a mixture, it'd be great actually if you could remind me. So speaking to the screen on 3, what is a mixture on 3? 1, 2, 3. Okay, so I'm hoping that you said that a mixture is where you have different substances that are together, but they are not chemically joined, or they are not chemically bonded, or they are not chemically combined with each other. And that's what a mixture is. It's when you've got different substances and they are not chemically combined. So we talked about different mixtures like water and salt, and we talked about mixtures like water and sugar. We talked about a mixture like if you have a metal and a non-metal, like iron and sulfur. Those are mixtures. You put them together, they don't chemically combine. You can separate them using different techniques. So one of the separating techniques we saw so far was filtration. You could pass a mixture through a filter paper, and if the substance is not dissolved in the water, it will get removed by the paper and the water or the liquid part will go through. Another separating technique was if you mix something with a liquid and it does dissolve. So you have maybe salt and water, you mix it with the water and it all dissolves up. You can put it into an evaporating basin and you can heat the mixture and you will evaporate the solvent and leave behind the solute. So you evaporate the water particles and you leave behind the solute particles. In today's video, we're going to be looking at a specific type of mixture, and that is a mixture of colored substances. So if we have an example, say we take red ink. So I'm going to draw just red ink. So if we take some red ink and we take some blue ink. Both of these things are pure substances. This is red ink and this is blue ink. Both of these are pure. Pure means they only contain one substance. Red ink is not made up of other colors of inks. It is pure. It is just one color. There's nothing else in there. You can't mix together different colors to get red. Blue is the same. It is a pure ink. There is no other colors in there. It's just blue ink. These are pure substances. But if we were to take them and mix them together, then we would make it a mixture because we would not only have one ink anymore. And that mixture would have a purple color. So this is purple ink. And purple ink is what we call a mixture. And that means that it is not pure. So the question is what if we took the mixtured inks, the purple one and other mixtures of inks, can we separate them again? Can we get back our colors? And we can do that, okay? We can do that using a process called chromatography. Chromatography. Now, chromatography, chroma is like an old Greek or Latin word which means color. And tography is a Latin word that means study. So chromatography means to study colors. Okay, and in chromatography, the basic way we would do this in school is, I can't show you this experiment, but we can talk about it and we can go through it. And that is here, if we take an example of, we have a beaker. So in this experiment, we would need a beaker. That would be part of the setup. So if you were asked in how you did this, I think we did this in class, or my class did. When you do this, you would need a beaker. That would be a piece of equipment you would need. What you would then need is you would need a piece of paper, and it would come in a strip, and me, the teacher, would have cut a strip of it for you. Now this paper is called chromatography paper. It's paper you use for chromatography. It's kind of like the filter paper. Feels kind of like the filter paper. It's chromatography paper. Now, in a chromatography experiment, there are two parts to the experiment. There is what we call the stationary phase. Now, the word stationary means does not move. Stationary phase. So the paper in a chromatography experiment is what we call stationary phase. This means it doesn't move. or it stays still. And the chromatography paper is the stationary phase. What we then need to do is about 2 centimeters from the bottom of the paper, just around here, we will put a pencil line. Now, it's really important to use pencil and not pen to draw this line. The reason for that is pencil is insoluble in water, and water is the solvent that we are going to use in this experiment. So really important that we use pencil, because if we don't use pencil, if we use a soluble substance like ink, then the ink will just wash off in the water, and that's not going to be any good to us. So we take our pencil line and we will draw a pencil line about 2 centimeters from the bottom of the chromatography paper. We would then take our purple ink and we will put purple ink in a spot on the line on the chromatography paper. What we would then do is we would take our chromatography paper and we will put it into our beaker. And in our beaker, we would have some water. Water, in this case, is a solvent. It's going to dissolve. It's going to act as a solvent to dissolve the purple ink. It's a solvent. And this is the second part of our chromatography experiment. The solvent is what we call our mobile phase. And the mobile, where would you have seen that word before? Well, you would have heard of a mobile phone. A mobile phone is a phone which can move around with you. It's not stuck in your home. It's not stuck to the wall in your house. So a mobile phone is a phone you can carry around and bring to different places. A mobile phase, in this case, is the part of the experiment that moves. So when we put our chromatography paper into the beaker, we make sure that the tip of the chromatography paper is below the level of the solvent. But you will note that the water is below, it's not as high as the line. It's below the line, it's below the ink spot. And this is really important so that it doesn't wash off the ink. So we've got, in chromatography, we use a beaker, we use chromatography paper, and we use a solvent, in this case, water. There is a stationary phase, which is the chromatography paper. It's stationary because it doesn't move anywhere. And there is a mobile phase. There is a solvent, which is a mobile phase. Now, why is it a mobile phase? Well, it's a mobile phase because the water is going to get sucked up the paper. So we would leave the experiment while the water moves up the paper. And we would stop when the paper is almost wet all the way up to the top. That's when we would know the experiment is over. And what we would typically see is we would see whatever colors are in the ink, and that would be red. We would see this trail of red, and maybe a spot of red, and the other ink, which is the blue ink, we would see that. So we would, basically, as the solvent moves up the paper, it's going to separate the purple ink into the colors that make it up. And that's going to allow us to see what pure inks are in the mixture of ink. So it lets us separate colored substances. This works for other substances, not just ink. But ink happens to be quite a useful one to use. Okay, so let's just recap what we know so far. Chromatography. Chromatography has 2 phases. So from memory, I want you to pause the video and I want you to write down the names on those arrows of the 2 phases. So you can start with what I have done there. Chromatography has 2 phases, and then tell me what the names of the 2 phases are. So I want you to do that on 3, pause the video and write those down. 1, 2, 3. Okay, so you should only be playing if you've copied that there, what I have done there, and you have written down, you've tried to write down what's on the end of those arrows. Okay, this is what you should have. The 2 phases are, this one is stationary, and this one is mobile. So we have the mobile phase and the stationary phase. Okay, on 3, I want you to tell me, I want you to write down what do those things mean. Okay, so what does the mobile phase do and what does the stationary phase do? Or what does those words mean? On 3, 1, 2, 3, pause the video. Okay, so I'm hoping that it says stationary phase means it's the bit, it doesn't move. The mobile phase moves. Okay, so on 3 then, I want you to tell me, in this experiment that we're talking about, which was the mobile phase and which was the stationary phase. Pause the video and add that detail. Okay, so you should now be watching if you've added that detail. Okay, and it should say it doesn't move is the chromatography paper, is the stationary phase. And the water is the mobile phase. Now, well done if you got that right. A quick reminder, guys, as I always say in my videos, if you are not doing these tasks when I ask you to, you are wasting your time watching these videos. You really need to make sure that you do the task. That's how you're going to learn. That's how you're going to learn from them. Okay, so at this stage, what I'm going to do is I'm going to get you to stop. I'm going to get you to have a look at these questions for me, and we're going to try and answer these questions. Now, I'm going to show you, I'm going to model for you how we should do the first one, okay? So question 1 says here, mixing yellow and blue ink can make green ink. Explain how green ink can be separated using chromatography. Use this structure. So this is telling you how you should start the sentences. So I'm going to model for you how you would get this started. So this is number 1, okay? So you can then use the bit that I've done and you can continue it. Well, it shows you here the starters of the sentences. So I'm going to use that. It says first, comma, a line is drawn. Right, so I'm trying to figure out, well, what's the next bit I would say here? Okay, well, given as much detail as I can, I would say a line is drawn 2 centimeters from the bottom of the chromatography. That's a good first sentence. Okay, full stop. What's the next bit? This is called. Okay, so this is called. Well, what is the chromatography paper called? So see, can you finish that sentence for me now on 3? Pause the video. 1, 2, 3. Okay, so you should be watching if you've tried to finish that sentence. I'm hoping that you wrote something like this. This is called the stationary phase. Great, well done if you got that. Excellent. Now, I've given you the next starter. Then, comma, a, okay, what's going to be next? Well, what was the next step? Well, I need to put the ink on the paper. So I'm going to say then a spot of, and then what color ink was it? It's green. Green ink, that's the mixture, is placed. Where do I place it exactly? It's placed on the pencil line. Good. Now, that's where the help runs out a little bit. So what I'm going to do is I'm going to stop giving you some help there now. I've helped you get it started. And you see here what it says, continue like this until you have a paragraph explaining how it is done. So I've helped you get it started. See if you can finish it using the same amount of detail as what we've done there. So go ahead and do that, and then do questions 2 and question 3. Okay, so you should only be watching this video if you have tried to finish writing the answer to number 1 and you have done 2 and 3. It's absolutely pointless just waiting for me to give you the answers. You're actually better off just turn off the answer, turn off the video, because you're not going to learn that. So you have to put pen to paper and try, guys. Okay, so I'm hoping that you wrote something like this for question number 1. Okay, so it should read something like this. First, a line is drawn in pencil on a piece of chromatography paper about 2 centimeters from the bottom. This is called the stationary phase. Then a spot of green ink is placed on the line. That's where we were. Okay, that's where we got up to. So then the detail I have is the bottom of the chromatography paper is placed in some water, which is a solvent. And the solvent is known as the mobile phase. Again, if you didn't have that kind of detail using the word mobile phase in your answer, you should probably try and put that in. Okay, notice the way I've only said that the bottom of the chromatography paper is placed in some water. So it only says here the bottom. That's an important detail as well. You don't want to stick the whole line. So that's a good detail to have. All right, the mobile phase is allowed to move up the stationary phase until the paper is wet up to the top. That's an important level of detail. How do people know when to stop? So that's a good level of detail to put in. The green ink will have separated into yellow and blue ink as it moves up the paper. So that is a good answer to that question. You should compare it to your own and see if you need to add any more detail, or if you've put anything wrong in there and you're looking now and go, actually, that probably doesn't belong there, then just get rid of it, okay? Right, the second question was, why is the line drawn in pencil? Use the word insoluble in your answer. The line is drawn in pencil because pencil is insoluble in water. And if you don't use pencil, if you use ink, it will just wash off. Number 3, why does the solvent need to be lower than the pencil line? The solvent needs to be lower than the pencil line so that it doesn't dissolve and wash off the chromatography paper. Okay, so you've got to have the water below the ink spot, basically. Now, guys, you will notice I'm using nice full sentences there. You guys should always do the same in these videos. If you're new to these videos, I expect full sentence answers, because the quality of your answers is so much better when you do it like that. Okay, and you will learn a lot more by doing that. Okay, we're just going to look at a couple more things now. So I'm just going back to my drawing board here. Okay. So what do we have at the end of chromatography? Okay, so at the end of chromatography, we have our piece of paper. So this is our chromatography paper, okay? And we have our pencil line, which should still be there. You still have your pencil line because it hasn't washed off because it was insoluble. So your pencil line is still there. Okay, remember it's insoluble, so it didn't wash off. And you might have some trace of your purple ink left, or your green ink, sorry. You might have some trace of your green ink that you put there at the start. But you will have the colors that make up green ink, which are blue. So we'll have somewhere on the paper, you will have some blue ink. You might have a little trail. And you will have the other color which makes up, which is yellow. And these will have separated at different points on the paper. So as the water has moved up the paper. And what will it look like? Well, it will be wet up to about here. And we'll make this a really thin line, okay? So it'll be wet up to about here. And that's how you know when to stop. When you can see the water line where the water's traveled up near the top of the paper, that's when you know where to stop, okay? So this is what we would call the paper at the end is what we call a chromatogram. Chromatogram. And it's what we look at the end to see what inks were in the, what mixture of inks, or what different colors of inks were in the mixture that we started with. Another thing to point out is that sometimes we don't only have to put one ink spot on our chromatography paper. We can put at the start, we can have our pencil line, and we could put 3 ink spots and compare them. So I could put a red ink spot here. I could put a blue ink spot there. And I could put a green ink spot there. I could put 4. I could put as many as I can fit on if I really want to. And then as they separate into their different colors, we can study them to see it and compare them to see if any of them have the same colors in them. Okay. So that's all possible. Okay. So it doesn't just have to be one. It doesn't just have to be one ink spot. So you can put lots of different inks on one piece of chromatography paper and then compare which colors they have in them. So this is the chromatogram. Chromatogram. This is what you're left with at the end, the chromatogram. Okay, right. So a couple more questions to practice now at this stage. Should be no problem for you. Oh. Right, this is a question for you. We've got a picture. A student sets up a chromatogram as shown in chromatogram 1. So chromatogram 1 is just here. This is chromatogram 1. And they have made 2 mistakes. So you have to say, what are the 2 mistakes and why will they ruin the experiment? So look carefully at the picture and look for 2 mistakes that the student has made and tell me why they will ruin the experiment. Again, guys, really important that you do this question. Don't just look and wait for me to do them. You won't learn anything like that. So pause the video and do them now, please. Okay, so you'll only be playing the video if you have spotted 2 mistakes and explained why they will ruin the experiment. You guys should be well able to do this. Okay, easy peasy stuff, I hope. Okay, so here are the 2 mistakes. The first mistake, they have drawn a line in ink. Look here. Start line drawn in ink. There's problem number one. Okay, why is that a problem? So I've said why it's a problem. Look, just go back and check my question. Checking my question. Look, I'm reading my answer. I said they have drawn the line in ink. Ink is soluble and will wash off the chromatography paper. I'm checking the question again to make sure I've answered it. Said they have made two mistakes. What are the two mistakes and why will they ruin the experiment? Okay, so actually I'm going to do that in different colors. Sorry. What are the two mistakes and why will they ruin the experiment? There's two parts to the question. Now in blue over here, I'm also going to highlight where I've done what are the two mistakes. So here is they have drawn the line in ink. There's one mistake. And another mistake is that the solvent is above the line. Look, the solvent over here is above the line. So here you can see solvent is here. It's above the line that they've drawn. So I've said what the two mistakes were. I'll go back to check the question. And in green, I had another part of the question. Why will they ruin the experiment? Well, they've drawn the line in ink. Ink is soluble and will wash off the chromatography paper. That's why it will ruin the experiment. And the second mistake, the solvent is above the line. This means that all the ink spots will dissolve and wash off the paper. So again, I'm always reading my answer and checking my question, make sure I've answered that. I'm happy now with how I have answered that question. Bang, job done. Good job. Right, another question for you now. Another couple of questions. I've got Chromatogram 2. Here it is. So a student tests 4 inks in Chromatogram 2. How many is the question? How many different colors is X made of? Okay, so how many different colors is X made of? So what I want you to do is I want you to pause the video and write down how many different colors X is made of. Okay, I'm hoping that you see that because X has 1, 2, 3 spots, here's X, here's X. Oh, sorry, I shouldn't scribble it. Here is X, and it's got 3 spots, so it's got 3 colors. So X is made of 3 colors is a full sentence there. Good job. Out of, that should say out of A, B, and C, which colors does X also have? So out of A, B, and C, which colors does X also have? So write that down now, if you can spot. So compare X to the other colors, A, B, and C. Which ones does it also have? Okay, so I'm hoping that you can see that X has colors at the same height here as C, and it's got one at the same height as B. It does not have one at the same height as A. So that's meant to be an X. It does not have one at the same height as A. So it contains, X contains A, X contains B and C, sorry, C and B. Contains C and B, but not A. Why can A be called pure and X can't? So pause the video and write down why can A be called pure and X can't. All right, so I'm hoping that you realize that A is only made of one color. There's no other color here, only one color, one color. So there's nothing mixed with it, whereas X is 1, 2, 3 colors. They have to be mixed together. And colors, when they mix together, don't make chemical bonds, because if they did, we couldn't separate them. So we have 3 colors. So that means that A is pure because it is made of a single substance or a single dye. That's the key bit there. X is not pure because it contains more than one substance together, which are not chemically combined. So I'm using my definition for a mixture there. Okay, guys, that's it for chromatography. Chromatography, separating different colored substances using chromatography paper and a solvent or water. Key phrases we learned were mobile phase and stationary phase. So very quickly, what is the mobile phase? Speak your answer to the screen. Hoping that you said the mobile phase is the part of the experiment that moves, or it's the solvent, it's the moving part. And what is the stationary phase? On 3, 1, 2, 3, speak out your answer. I'm hoping that you said the stationary phase is the bit of the experiment that stays in the same place. It doesn't move. This is the chromatography paper. Okay. What is the piece of paper after the experiment is finished? What do we call that? On 3, what is the name of that now? 1, 2, 3. I'm hoping that you said it's called a chromatogram, and it's what we study at the end to see what colors were in our mixture of ink. Okay, well done, guys. I hope you learned a lot today. Do me a favor, if you found the video useful and you learned some stuff from it, which I'm pretty sure you would have if you've done it properly, just leave a like on the video, because it will help other students from other schools who might be struggling with these ideas to find the videos and help other people. And also, if you have any videos you would like me to cover, if you're struggling with something in your revision of your exam papers or something, do stick a comment in the comments and ask me to make a video on it, and I'll get around to it as soon as I can. Okay, guys. See you in the next video.